Hello students, today we are going to study about the tangent and secant properties of a circle. I will be taking the important theorems, showing it mathematically and showing the mathematical information which we get from. So starting with the first theorem, it says the tangent and radius at the point of contact are perpendicular to each other. It means here, first of all, we should know it nicely what a tangent means. Tangent is an external line from a point outside the circle and touching the circle only at a point. Like in this diagram, it is touching at the point P. So, APB is a tangent. Now, this is the point of contact. If we draw a radius joining the center with this point of contact, let us draw it. Then the theorem says that the tangent and the radius will be perpendicular to each other. It means the angle formed here will be 90 degree. So what we can relate is in this way. If OP and AP are radius and tangent. Okay, what I have written here is that OP, this one, and APB are radius and tangent. Then what we get? Then OP is perpendicular to AB. So whenever this will be happening, we will be taking this angle as 90 degree. Now, if I join this line OA, we get a right angle triangle. So in this triangle, Pythagoras theorem can be applied, and any of the side which is unknown when two sides are given can be calculated, and this theorem in most cases will be used for this purpose only. Students, now we move to the second theorem. Second theorem is the lengthy one. It has got three parts, but a very important part. Theorem says if two tangents are drawn from an external point to a circle, then so this is a circle drawn, center is here, point P is an external point, and from here two tangents EA and PD are. This entire line is a tangent, but the length of the tangent is from P to A. PA is the length of the tangent, same way PB is the length of the tangent. Never take the length of the tangent from this point to wherever you draw it. The meeting point of the circle till that point from the external point is your length of the tangent. The first part, the lengths of the tangents are equal. It means the length of PA and PB are equal. So, according to the first one, we get the length PA and PB are equal. And remember that if we have an external point, we can draw only two circles to it, and both of them will have the same measurement. Okay, that is what the first part says. Now to the second part. The tangents subtend equal angles at the center. Now this is a tangent to it. So angle subtended by it will be the angle made by the joining of AO and BO, and by the joining of BO and OB will be the tangent made by PB. So let us draw those two tangents. Okay. So now you can see that PA, the tangent PA is subtending angle POA at the center, and tangent PB is subtending angle POB at the center. And according to the theorems, the angle measure of both of them will be equal. So we will get here in the second part, angle AOP is equal to angle POP. That's the second part of the theorem. Now to the third part. The tangents are equally inclined to the line joining the point and the center of the circle. Now see, this is the line which we get by joining the external point and the center of the circle. So theorem says these two tangents are equally inclined. Equally inclined means the angle made by the tangent and the line joining the center on both the sides will be equal. So let me mark it. So these two angles we are going to get it equal. So mathematically we write it now. Angle APO is equal to angle BPO. So in one theorem, it is here three parts are there. So let us recall them, go through it again. So theorem says that whenever from an external point we draw two tangents to a circle, and only two tangents can be drawn. First part says that the length of the two tangents will be equal, PA equal to PP. Second part says the angle made by these tangents at the center will be equal. So that is angle AOP equal to angle POP. And the third part says that the tangents are equally inclined to this line which is joining the center with the external point. So angle APO will be equal to angle BP. So now we start with the third theorem regarding the tangent and secant properties. But you will find here that actually tangents are not drawn. Okay, now follow what the theorem is. The theorem says if two circles touch each other externally or internally, then the point of contact lies on the line joining their centers, and the distance between their centers is equal to the sum or difference of the radius respectively. So follow what it says. Now two circles touching each other externally. This is the diagram for it. This is the first circle with center A having a radius capital R. Second circle is with center B having a radius small r. This is the point where they are touching each other. It is not intersection of circles, it is the circles touching. This is the point of contact. So theorem says if they are touching externally or internally. Now coming to the internal part. This is a bigger circle with radius capital R, center A, and this is a small circle with radius small r and center B. Now both of them are touching internally. From the inside they are touching. So the point of contact is here for the internal. Theorem says the point of contact lies on the line joining the centers. So you can see the center A and B are joined, and the point at which the two circles are touching, it is passing through that area. So it means APB is a straight line. Then here also for internal touching, AB, when extended, it is coming and meeting at the point of contact only, not at any other point. So here also now ABB is a straight line. This is the first part of the theorem where they are touching. The point of contact lies on the line joining their centers. Now the second part is the important part. When they are touching externally, the length or the distance from one center to the other is the sum of the radii. So it means I can write here AB equal to the capital R radius of the bigger circle plus small r the radius of the smaller circle. So this sum part is there for external when they are touching. Now coming over here, the distance between the centers, that is AB, give me here difference of the radii. Difference part mentioned, difference of the radii. So the bigger circle radius capital R, difference is minus. So the radius of the smaller circle. Okay, that gives you the conclusion of this third theorem. Now we start with the fourth theorem, which is based on chord and secant. You can see this line, this chord AB and CD are reduced to meet at a point. Secant is any external line which cuts the circle at 2 points. So ABP is a secant, CBP is also a secant. Now what this theorem is about? It says if two chords of a circle intersects internally or externally. This is internal intersection, this is external intersection. Then the product of the segments are equal. Okay, then the product of the segments are equal. Here it is not the segments of a circle but line segment. So if this is a chord AB and CD intersecting at point P, we get two line segments AP and PB and CP and PD. So from one chord AB we have two line segments AP and PB. So their product will be AP into PB. And same way, then from CD you have two of them, CP and PD, and their product will be CP into PD. Same way here, externally it is making. So this AP is one of the line segment and BP is another line segment. So their product AP into BP will be the same as the product from the next part of the chord CP and PP. So for both of them, the result coming up will be this, that is PA into PB will be equal to PC into PP. So in both of them, whether they are making it internally or externally, the condition which comes is this one. So when you get sums based on this, there are 4 parts to it. Basically, 3 parts will be given, you will be asked to find the 4th part. Okay? And how you can do the proof of it? If you just join them over here also, you will get 2 triangles, you prove them similar, write the sides in proportion, cross multiply. Hello students. So moving on to the next theorem based on tangent and secant properties of circle, we come to theorem 5, which is also named as alternate segment theorem. The theorem says that the angle made by the tangent and the chord at the point of contact is equal to the angle made by the chord in the alternate segment. It means, follow from the figure, I draw a circle. I've got a tangent here, EAT, which is touching the circle at point A. So this is the point of contact. It says, and the chord drawn at the point of contact. So the moment this is drawn, we get angles made by the tangent and the chord. One of the angles I will be marking here, that is this particular angle. So this is one of the angles made by the tangent at the chord. So this is angle BAT. Now this angle which will be there will be equal to the angle made by this chord in the alternate segment. Now you need to understand what is alternate segment here. If I have drawn a chord, this angle which I have marked made by the tangent at the chord is in this part of the circle, which is a segment of a circle, and this is called as the same segment. Where angle is formed, that is the same segment. So this part which is left is your alternate segment. Now this chord AB forms any angle in this alternate segment. That angle will be equal to this. So let me draw one such angle. So I have taken lines from point A and point B, made it to meet at in the circumference part of the alternate segment, and that is point I have named as C. So this angle will be equal to this angle. This is what this theorem means. Okay. So according to this, then I go to write angle EAT is equal to angle ACB. Now the same thing I will show with the other figure so that the other segment can be used. So here I am marking that this angle, which is obtuse angle over here. So this is the angle EAT made by the chord and the tangent. So this angle is now making use of this part of the circle. So this becomes the same segment for this segment. So this smaller segment which is there becomes the alternate segment. So now the chords will be making angle in this part, in the minor segment here, for it to be equal to this angle over here. So now this angle will be equal to this angle, because this is the angle made by the tangent and the chord in this segment. So this segment becomes the same segment and the other one becomes the alternate segment. So they will be equal. So if I write according to that, it comes to angle EAP equals to angle BDA or ADB. Very important theorem. Every year a question based on this theorem comes in the board examination. Okay, and when we make use of this theorem as a reason, instead of writing the entire thing, you can also write alternate segment theorem as the reason. Hello students, now we move to the next theorem where tangent as well as secant will be coming in the same theorem. Theorem says that if PT is a tangent and PAB is a secant drawn from an external point P, then PT square is equals to PA into PT. So this is a circle drawn. This is the PT is a tangent and PAB is a secant. The secant is cutting the circle at the point A and B. So PA means the length from here to here and PB means from P to the point where it is touching the circle or cutting the circle. When this happens, always this relationship will hold, that is PT square will be equal to PA into PB. So you find a tangent is given in the figure and the secant is given, and we have to find length of any line segment. We can make use of this theorem. So usually you can see there are 3 different lengths here. Out of that 2 will be given and you will be asked to find the third one. When this theorem comes, you can write in the reason as tangent secant theorem instead of writing the full statement. Thank you.